And here are still a lot of issues. This is an example of the sales performance of salespeople and of a sample of salespeople. So this is a person, this is a salesperson. And they show this sales performance, and this is sociability, the ability, personality characteristic to be sociable. Sociability, they have that personality characteristic from 0 to 100. This is also from 0 to 100. And here you see that this is the scatter plot, the ceiling line, and this is the line through the middle of the data, or in other words, the regression line, the OLS, ordinary least squares regression. Is this language that you understand, ordinary OLS? Yeah, okay. So this is what we normally do, line through the middle of the data to show the average trend. So there's an average trend. The more sociable, on average, the more sales performance. And this is the line that I'm interested in. And you see there are two lines here. We are now trying to find out what is the best line, the best top line. That's not easy. There's a lot of discussion on that, and we are trying a lot. And as I said, the regression was about 100 years old. Before we found out that the least squares line was the best line from statistics point of view, there were other alternatives of middle lines. You can imagine least squares is the vertical distance of every point to the line is minimized. But you could also have the perpendicular distance, or even horizontal distance, or even other criteria. In the past, they have been trying to find a good line, and now it is completely accepted that it should be the least squares line from certain statistical reasons. So the state of the art of the ceiling line is that we don't know yet what is the best line from statistical point of reasoning. And we are now doing all kinds of simulations to figure that out. It's not so important. The only thing is that there is a kind of a line, and there are some alternatives here. Sometimes a bit higher, sometimes a bit lower, etc. This is what we call the CEFDH line. This is the ceiling envelopment free disposal hull. Forget the name. Line, and that is this step function. So there's no point above it. All those corner points at the top are connected. So, and this is then defined as the empty space. This line is the ceiling regression free disposal hull. Forget the name again. And this draws a trend line through those corner points. So to have a linear model, and this is a step model.
So that's the least square of the corners?
Yes. Yes. And we are also trying the weighted least square. That is detail at this moment. It's not for, we probably will come up with another line soon, but we are not sure yet.
Plus there you have some, if you have very few points, you have some
points above it.
Yeah,
Exactly. Yeah. By definition, this line, it's nice because it's a line, like the OLS line is also a line, and not something like that. Could be, but we haven't chosen for that in the society, to make there a step function. Could also be done like that. But so if you choose a line like this, the ceiling line, you have points above it. We call it inaccuracy. I'll come back to that later a little bit. So drawing the ceiling. So this example, you have defined. I use this line now. So we have what we call the ceiling zone is the empty space above the line. This total zone is called the scope. So this is where you, given the maximum x and the maximum y and the minimum x and the minimum y, this is the scope. You divide the empty space in comparison to the total space, that's called the effect size, which can have a value between 0 and 1. So it is a kind of the size of the necessary condition. And it is a kind of a constraint, you can call it. The lower the line, the more x constrains y. So the larger this space, the more necessity effect x has on y. Therefore we call it an effect size. And the accuracy is the percentage of observations on the line or below the line. So accuracy in this case is 97% and the effect size is 0.19. So almost 20% of the total space is empty.
But that accuracy number is you only use that when you have the CR ceiling type.
You can also use it with the other one, but then it's 100%.
Exactly.
Yeah. The one is per definition 100%, and other lines have usually some inaccuracies. We also formulate what we call the bottleneck table. Basically, that is the ceiling line, but in tabular format. So here you have the sales performance from 0 to 100, and here you have the X, the sociability, also from 0 to 100. And what it says here, for example, if you want to have 40% of sales performance, if that's the ambition of the organization, sociability is not necessary, because you can have, for any value of sociability, it is possible to have 40% of sales performance. So if you are an organization that is not that ambitious regarding sales performance, you don't care about the sociability of your sales force. Same for 60%. But at the moment that you want to get into the top, for example here, 70%, you need to have your sales force to have at least a bit of sociability, 23%. And it goes up. So if you want to be a top performer on sales, your sales force must be really sociable.
But if you use the step function, you can get away with a slightly lower level.
Yeah, it's no, sure. It is dependent on this is dependent on the line. This suggests accuracy. Really, depends on the line. Which is also true, by the way, for the or less regression line, because if you take another line, the regression coefficient would be different.